Hi everyone. So today we're going to be proving that the equation sine of 2x times the sine of 6x doesn't have any real solutions. I'm going to be doing this problem in two ways. The first one I'll show the first one in this video, and I'll show the second way in the other video. Okay, so here we have a product of two sines. So one of the things that we could do that's going to help us get our solution is turn them into a sum of some other trigonometric functions. So cosine of alpha minus beta is equal to cosine alpha times cosine beta plus sine alpha sine beta. And the cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. Okay, now when we take this, when we subtract the second equation from the first one, we'll get that cosine alpha minus cosine of alpha minus beta minus the cosine of alpha plus beta is equal to 2 times sine alpha times sine beta. Okay, so when we divide both sides by 2, we'll get that sine of alpha times sine of beta is equal to 1 over 2 times the cosine of alpha minus beta minus the cosine of alpha plus beta. Now, when we apply this equation to our original equation, we see that we can rewrite sine of 2x times sine of 6x as 1/2 times the cosine of 2x minus 6x is negative 4x. But since cosine is an even function, that means that the cosine of negative 4x is exactly the same as the cosine of positive 2x, and minus cosine of 2x plus 6x is equal to cosine of 8x, and this all together is equal to 1. Now we can go ahead and multiply both sides by 2, so we'll get that cosine of 4x minus the cosine of 8x is equal to 2. Now when we go ahead and rewrite cosine of 8x as cosine squared of 4x minus sine squared of 4x. So we just rewrote cosine of 8x. We just used the double angle formula for cosine. And all of this must be equal to 2. Now let's go ahead and remove our parentheses. And when we do that, we'll get a plus here. Now let's go ahead and rewrite this yet again as cosine of 4x minus cosine squared of 4x plus, and sine squared of 4x is just 1 minus cosine squared of 4x, and all of this is equal to 2. Now, when we rewrite this in a slightly better manner, we'll get that this one and this one minus 2 times cosine squared of 4x plus cosine of 4x, and 1 minus 2 is equal to negative 1 is equal to 0. Now, since I don't like the a term to be negative, I'm just going to multiply everything by negative 1. The solutions to the equation, if they exist, will stay exactly the same. So 2 cosine squared of 4x minus cosine of 4x plus 1 is equal to 0. And this, of course, is a quadratic equation in terms of cosine of 4x. So let's go ahead and use the substitution. Cosine of 4x is equal to t, which will give us 2t squared, which will give us 2t squared minus t plus 1 is equal to 0. By using the quadratic formula, we'll get that t12 is equal to 1 plus or minus 1 minus 4 times 2 times 1, 1 minus 8, and everything over 2. Since 1 minus 8 is just the same as negative 7, this already proves that this equation does not have any real solutions. Okay, and if this equation doesn't have any real solutions, the original equation can't have any real solutions as well. So this is our final answer. So the discriminant is less than 0. So this is our final answer to our problem. I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one.